5 different types of transformations are provided to transform parts. The 5 different transformations that are allowed are coordinate transform, scaling, translation, rotation, and reflection. The first option that we are going to see is transform coordinate system. Transforming a part to a coordinate system moves a part from a position relative to a source coordinate system to a position relative to a destination coordinate system. This transform is useful for both translating and rotating a part in the same operation and maintains the exact shape of the part during the transformation. Next is scaling a part. Why is scaling necessary? You can scale a part if it uses units that are different to other parts you have already imported. Scaling can take place in any or all of the 3 coordinate directions and can be used to increase or decrease the size of a part. The next transform operation is translate. Translating a part can be used to rearrange the geometry so that it fits together as intended. This problem can arise when different parts are built in different coordinate systems. Translation can take place in any of the 3 coordinate directions. Now, we will see rotating per operation. You can rotate a part to reorient it with other static components. Rotation is allowed in any axis direction. The next operation is duplicating a part. You can duplicate a part in instances where only a half, quarter, or some fraction of a symmetrical or axis symmetric model has been imported and the full geometry is desired instead. Duplicating a part produces an identical copy of it with the same properties as the original, other than region and contact specification, which are left null. The duplicate also occupies the same location as the original until it can be transformed. If a 3D CAD part is duplicated, the duplicate copy is a leaf-level CAD part rather than a 3D CAD part. The link to the originating 3D CAD model is lost. How to combine 2 parts? 2 or more parts can be combined to create a single mesh part. To combine parts, select the Parts node of interest. Right-click and select Combine from the pop-up menu. The first selected part is used as the base for all the other parts. The next operation is unite part. The Boolean operation unite parts joins all the selected parts into one single part. The surface of this new part is formed from segments of the constituent part surfaces. This is unlike the combine operation, which combines the selected parts into one part but retains the part surfaces as separate whole surfaces. To carry out a unite operation successfully, the selected parts must be in contact with each other or overlap. A unite operation can be performed on a combination of leaf-level and or composite parts or on a single composite part that contains at least 2 other parts. Next, we will see an important operation of splitting parts. In star CCM Plus, there is an operation called split part by surface topology. The split by surface topology method can be used to split and combine parts that can be defined as distinct geometrical regions. It is similar to the method used to split regions. The operation is based on the topology of closed, manifold, non-intersecting surfaces that the parts define. Using this operation, we can do different things like separate two or more closed surfaces that are not in contact into two or more parts. Separate two or more closed surfaces that share a common interface. Create new parts from internal voids. Redefine the surfaces of parts that contain closed surfaces or other whole parts. Let us see an example of split part by surface topology. As shown in the figure, first we have a complete body called body 1 with a surface topology defined in such a way that we have an inner cylindrical surface. When we use split part by surface topology operation, we get two bodies. Body 1 hyphen 2, which is the block, while inner body 1 hyphen 3, which is the inner cylindrical region. The next operation is intersect parts. This operation finds the common volume that the selected parts share and creates a single part that is based on this volume. The surface of the part is formed from segments of the constituent part surfaces. To carry out an intersect operation successfully, all the selected parts must share a common volume. If the parts do not share a common volume, the new part that this Boolean operation creates contains no surface data. As intersect operation can be performed on a combination of leaf level and or composite parts, or on a single composite part that contains at least two other parts. Next, we have subtract parts operation. This Boolean operation subtracts a defined shape from the volume of a target part. Any number of parts can be used to define the shape to subtract. The surface of the resulting part is formed from segments of the constituent part surfaces. A subtract operation can be performed on a combination of leaf level and or composite parts, or on a single composite part that contains at least two other parts. For splitting parts, there is one more option called split non-contiguous parts. First, what is a non-contiguous part? This is a mesh part that has faces that are not connected to other faces in the part. Incomplete. After transform and Boolean operations, the next most important task while handling geometries in CCM Plus is surface preparation. Why do we need to prepare surfaces? Let us see. It is possible that the surfaces of your geometry are not in a suitable condition for surface meshing. Among other things, there can be faces on the surface that intersect other faces or edges that have two or more shared faces. It is good to practice to check the validity of the surfaces on your geometry before you attempt to generate a surface mesh. Thus, we have to do some surface repair or preparation before we generate surface mesh. The surface preparation tool provides diagnostic checks for assessing the validity of surfaces and a range of tools by which surfaces can be repaired. The Edit tab appears containing the surface preparation tool. The surface preparation tool uses various methods for surface repair or preparation. Let us list them here. Surface diagnostics, surface repair, feature curve repair, face offset tool, connected surfaces edit, merge imprint tool, face intersection tool,